For decades, the T-series of battle tanks was the ultimate symbol of Soviet and later Russian military strength. It represented mechanized decisive power, a vast steel juggernaut designed to sweep across the plains of Europe. The image of the low-profile, mass-produced T-series tank was synonymous with Moscow's ability to deliver force. Yet, 2 years into their full-scale invasion of Ukraine, Russia has seen the image of the T-series broken into thousands of burning pieces scattered across the steppes. The sheer scale of the Russian tank debacle is not merely a tactical setback, it's a historic disaster. So let's find out why Russian tanks may be at the end of the road. First, the use of Russian tanks in Ukraine is nearing an end, just because of isolated tactical blunders or poor crew training. Instead, it's because the entire operational concept of Russian armour has been rendered catastrophically obsolete. This terminal failure is the result of a collision between three insurmountable forces: a fatal design flaw baked into every Soviet-era hull, the introduction of a technologically superior and asymmetric kill chain, and an unsustainable war of attrition where manufacturing capacity cannot match the frontline rate of destruction. The war in Ukraine has become a laboratory for modern combat, where cheap, plentiful technology is consistently defeating expensive heavy metal. The Russian main battle tank has gone from being a decisive weapon to a high-value, easy-to-destroy target. From the earliest days of the war, the world watches countless images of decapitated tanks, their turrets blown apart, demonstrated a fundamental terminal vulnerability. The most profound vulnerability of Russian armour lies deep within the genetics of its engineering. The 3 decades of Russian tank design built upon a fateful structural compromise. This is not a failure of maintenance or tactics, but a failure of doctrine that prioritised low profile and mass production over crew safety and repairability. Since the T-72 was introduced in the 1970s, Soviet engineers sought to create a tank that was smaller, lighter, and easier to conceal than its NATO counterparts. This effort was driven by the post-World War II Khrushchev-Brezhnev doctrine, which called for a massive, decisive mechanized thrust into Europe, relying on overwhelming numerical superiority. This choice was inherently philosophical. Western militaries prioritized the survivability of their highly trained crews in a prolonged fight, whereas Soviet doctrine viewed tanks as expendable assets that could be quickly replaced. This led to a key metric advantage. The T-72's hull-down presentation and overall height, 2.19 meters, was substantially lower than those of its Western counterparts, the NATO's M1 Abrams, 2.39 meters, and the German Leopard 2, 2.48 meters. This small silhouette was a major design priority for defensive positions and avoiding detection in a large-scale European conflict. However, T-series tanks are notoriously cramped, adding to crew fatigue and making combat operations more difficult compared to the spacious fighting compartments of NATO tanks. To overcome this space limitation, weight and cost had to be minimized. The primary means of achieving this was the incorporation of an automatic loader. This mechanism replaced one crew member, the loader, allowing the tank to operate with a 3-person crew and significantly reducing the overall vehicle volume required. But while the engineers successfully optimized for size and mass by installing an auto loader, it came at a hidden fatal cost to internal layout and crew ergonomics. The specific design choice for the auto loader created the tank's single greatest weakness. The main gun ammunition storage, a carousel holding between 22 and 40 high explosive shells and their volatile propellant charges, is positioned in a ring directly beneath the turret and the crew compartment. This placement, necessary to keep the profile low, makes the tank a giant volatile bomb waiting for a pinprick. This inherent structural fault runs through the entire spectrum of Russia's deployable armour, including the original T-64, the widely used T-80, and the current top-tier model, the T-90. The moment an enemy projectile penetrates the relatively thin side or bottom armour and strikes this carousel, a runaway chain reaction begins. This internal detonation results in a massive and uncontrollable catastrophic explosion. The initial charge ignites the surrounding propellant charges, turning the tank interior into a high-pressure furnace. The pressure buildup inside the sealed hull is instantaneous and enormous, forcing the explosion to vent through the weakest point, the turret ring. The result is the infamous jack-in-the-box effect, where the 12-ton turret is violently torn from the chassis and sent flying skyward. This turret toss phenomenon has become the signature visual hallmark of Russia's armoured failure, signifying the instant destruction of the vehicle and the death of its three-man crew. In stark contrast, modern NATO designs followed a doctrine of prioritising crew survivability. Tanks like the Abrams and Leopard 2 store their ammunition in an armoured compartment in the turret bustle, the rear section. This storage area is separated from the crew by an armoured bulkhead and fitted with blowout panels, lightweight sheets designed to fail and direct the force of any ammunition explosion outwards and upwards, away from the crew. This design means that while an Abrams can still be knocked out, its crew frequently survives, allowing them to escape and the vehicle to be recovered for repair. The design choice essentially trades a slightly higher profile for crew survival and vehicle recoverability. The difference in doctrine is clear. A successful hit on a Russian tank is a total kill. A successful hit on an Abrams is often only a mobility kill with the crew surviving. For Russia, the consequences of this design flaw are twofold. First, the material loss is virtually always 100%, as a T-series hit is rarely recoverable, leading to an unrecoverable strategic drain on assets. Second, and more critically, the loss of experienced, highly trained crews is instantaneous. Tanks can be replaced with older models. Experienced tankers cannot. This continuous loss of human capital is an exponential drain on the Russian military's ability to conduct complex combined arms operations. The structural vulnerability of the Russian tank, once an acceptable risk in the calculus of Cold War tank warfare, is now exploited by a technologically superior and asymmetric kill chain. The battlefield has shifted from a domain of heavy metal versus heavy metal to one of precision sensors, cheap mass-produced systems, and pervasive electronic warfare. In the opening phases of the war, the influx of advanced Western anti-tank guided missiles, ATGMs, provided Ukrainian forces with an immediate, overwhelming advantage. The FGM-148 Javelin from the US and the NLAW, a product of UK and Swedish technology, proved devastating precisely because they countered the Russian tank's heavy frontal armour. The Javelin missile is famed for its unique top-attack flight profile. Launched by a single infantryman, the missile climbs hundreds of feet before descending to strike the tank's roof, where the armour is at its thinnest, often less than a few inches of steel. This tactic bypasses the thick, reinforced glacis plate that Soviet doctrine emphasized. Moreover, the Javelin's tandem charge warhead easily defeats the reactive protection on modern armour. Russia's latest explosive reactive armour, ERA, such as Relict or the new Malachite systems found on the T-90M, requires complex engineering to defeat multiple incoming charges. The tandem warhead ensures the first, smaller charge detonates the ERA tiles, clearing the way for the second main charge to penetrate the underlying steel. This has rendered Russia's ERA systems, which were once considered state-of-the-art protection, largely obsolete against high-end missiles. The psychological impact of the Javelin is as significant as its destructive power. Its fire-and-forget capability, enabled by an imaging infrared seeker, allows the operator to lock onto the thermal signature of the tank and immediately seek cover before the missile impacts, greatly increasing the survival rate of the defending infantry. This dynamic turned every road, forest edge, and urban block into a potential ambush site, creating a lethally decentralized defense that Russian armored columns simply couldn't overcome. This ability to deliver a devastating targeted strike from a concealed position is the core of modern asymmetric warfare. While ATGMs delivered the initial knockout blows, the sustained paralyzing threat to Russian armour comes from the low-cost, high-volume production of first-person view or FPV kamikaze drones. These systems, often costing as little as $500 per unit, less than a single tank shell, function as miniature anti-tank missiles, creating a new persistent kill chain that operates 24/7. The proliferation of these drones has made the front highly transparent to a depth of 10 to 20 kilometers, denying Russian armor the ability to maneuver unseen. The tactical shift is profound. Instead of focusing on a total kill, FPV drone operators often aim for a mobility kill, disabling the tracks, the engine deck, the sensitive optics, or the main gun barrel. If a Russian tank breaks down, is stationary, or attempts to dig in, an FPV drone will find and destroy it, or at least incapacitate it, leaving the high-value asset stranded and subject to subsequent artillery or follow-up drone strikes. The sheer volume is staggering. Reports indicate over 50,000 FPV drones are deployed monthly by Ukrainian forces. This has led to the adoption of sophisticated swarm tactics, where multiple drones are launched in a coordinated, decentralized manner to overwhelm a single target or its accompanying electronic warfare or EW defenses. Some sophisticated FPV drones are even becoming AI-enabled, utilizing computer vision systems to recognize and lock onto targets even if communication or GPS signals are jammed. Meanwhile, the use of loitering munitions, like the Russian-made Lancet against support vehicles and self-propelled artillery units, ensures that the logistics chain necessary to support tanks is also under constant intense pressure, contributing to the systemic logistics crisis. The ultimate indictment of Russian tank doctrine is its profound lack of integrated, modernized active protection. While NATO tanks like the Abrams and Leopard 2 have been aggressively integrating active protection systems, or APS, like the Israeli Trophy and its American equivalents, Russian tanks rely almost entirely on passive and reactive armor. The Kremlin possesses indigenous APS technology, notably the Arena system and the more advanced Afghanit planned for the T-14 Armata. However, these systems have failed to achieve widespread deployment across the main operational fleet of T-72s, T-80s and T-90s due to prohibitive cost, logistical complexity, and the inability to produce key electronic components under sanctions. An active protection system uses millimeter wave radar to detect incoming projectiles like ATGMs or RPGs, and fires a small counter-munition to intercept and destroy the threat moments before impact. This is the only reliable defense against the high-velocity, shape-charged threats dominating the Ukrainian battlefield. Without it, the Russian tank is a sitting duck. The reliance on explosive reactive armor, or ERA, like Contact 5 or Relict, is a defensive philosophy rooted in the Cold War. ERA, which uses explosive tiles to disrupt a shape charge upon impact, is a passive defense. It's highly effective against older RPGs and certain kinetic penetrators, but is fundamentally defeated by tandem charge warheads like Javelin and the NLAW, and is totally ineffective against the vertical dive of an FPV drone striking the tank's least armored roof. The complete failure to adapt to multi-vector threats reveals a systemic flaw in Russian military procurement that extends beyond sanctions. It's a failure to map the battlefield vulnerabilities accurately. Russian command failed to recognize that the proliferation of low-cost, precise munitions would render their low-profile but catastrophically vulnerable design utterly non-viable. The lack of integrated APS means that Russia's frontline armor, despite sporadic upgrades, operates as a passive target in a modern theatre dominated by active defense. Every successful hit on a passive target is likely a catastrophic kill, amplifying the lethal effect of the T-series design flaw. This doctrine of relying on outdated reactive armor and ignoring the need for counter-munitions and active sensor fusion is the final strategic nail in the coffin of Russia's armored might. The Russian military entered the conflict boasting world-class EW capabilities, but these systems have failed to protect their armored formations in a consistently effective way. While large-scale systems like the R330 ZH Zytel or Lear-3 are designed to jam communications and GPS across a wide area, they're often bulky, vulnerable to artillery, and slow to deploy. Crucially, the protection for individual armored vehicles has been consistently outpaced. The use of crude, field-expedient Tsar Mangals, or improvised overhead cages onto the tops of their tanks is a visible admission of the systemic failure of the integrated protection systems. These cages, intended to prematurely detonate incoming drone warheads, proved ineffective, making the tanks heavier, less mobile, and prone to overloading the transmission. The desperation of welding these crude add-ons, which often failed to fully shield the vulnerable rear and sides, highlights the disconnect between the MIC's promises and the operational reality on the southern front and other key sectors. The pervasive and adaptable nature of the commercial FPV drone technology has simply overwhelmed the slower, more centralized Russian counter-drone efforts. The final, unassailable factor confirming that Russian armor is Finnish as a decisive force is the simple but devastating economic and industrial reality. Attrition far outstrips production. The scale of material loss is documented with unprecedented transparency. Through open-source intelligence efforts, notably by organizations like Oryx and the Conflict Intelligence Team, CIT, the visually confirmed destroyed Russian vehicles are a public record. Independent analysts estimate that Russia has lost over 3,000 tanks, a number equal to the entire pre-war active inventory of the Russian army. This staggering rate of loss means Russia is essentially fighting the war with borrowed, old and increasingly fragile equipment. To compensate for these catastrophic losses, Moscow's primary source has been the vast Soviet stockpiles stored at dilapidated reserve bases across the country. The systematic withdrawal of tanks for refurbishment has been relentless, resulting in many of these reserve bases being depleted of usable platforms. Satellite imagery has shown a clear drawdown of stored vehicles. Russia is now forced to restore deeply obsolete models like the first-generation T-62 and even the post-World War II T-55. These tanks offer almost zero protection against any modern ATGM or FPV drone. Furthermore, the restoration process itself is fraught with compromises. Refurbished T-62 and T-55 tanks often lack essential modern systems like Advanced Fire Control Systems, FCS, modern digital communications, and thermal imaging optics. Their older engines and chassis are prone to breakdown, especially when outfitted with improvised heavy armor additions. Crews operating these aging tanks are forced into environments for which their vehicles are completely unsuited, frequently suffering immediate destruction upon reaching the front line. This strategic siphon of its usable reserves has led to a dramatic and irreversible qualitative degradation of Russia's armoured fighting capability. The second avenue, new production and modernization, is severely constrained. While Russian state media boast of rising output, the reality for factories, like Uralvagonzavod, is a battle against economic isolation. Western sanctions have crippled the Russian military-industrial complex, the MIC, by cutting off access to crucial Western-sourced components. Key to modern tank performance are high-specification parts like thermal imaging optics, historically sourced from French companies like Thales. Precision machining tools for cannon manufacturing, historically sourced from Germany or Switzerland, and high-quality microchips for advanced fire control systems. The ban on these components has forced the MIC to rely on inferior, older, or illicitly acquired alternatives. The production of the top-tier T-90M has slowed dramatically, and the few tanks produced are often degraded models. This practice of using lower-grade, non-military chips, sometimes scavenged from civilian appliances or routed through a complex web of intermediaries in China and Kazakhstan, leads to unreliable performance of the vehicle's electronic systems. These clogged supply chains and the high cost of sanctions evasion force Russia to pay nearly twice as much for these inferior components. The reliance on dual-use technology that was never intended for military use at the front lines creates massive operational liabilities. The innovation stagnation at the heart of the Russian MIC means that while production numbers may tick up, the quality of the final product is inherently lower, cementing the strategic failure. The Russian tank, defined by a flawed Cold War design and now starved of the modern technology needed to survive, is an artifact of a failed doctrine. The combined arms failure that plagued the initial invasion, where tanks advance without sufficient infantry support, air cover, or a coherent logistics crisis, has been cemented by the systemic failure of the vehicle itself. The tanks that roll into Ukraine today are technologically outmatched, doctrinally misapplied, and fundamentally flawed. There are fewer assets for victory and more liabilities for the crews forced to drive them. The strategic failure of the Russian offensive is now inexorably linked to the tactical failure of its primary weapon system. The Russian tank is no longer an armoured spearhead. It's now a mobile funeral pyre, whose inherent design flaws have been perfectly exploited by the combination of high-end anti-tank systems and low-cost mass-produced drones. Moscow's inability to adapt its industrial base and tactical doctrine to this reality has turned the conflict into a slow, guaranteed destruction of its once feared armoured forces. The failure of the T-series tank is therefore not a temporary setback but a permanent indicator of Russia's declining status as a modern military power, marking the end of the Cold War era of mass-produced, expendable armour. The inevitable obsolescence of the tank as a decisive weapon for Moscow is now priced in. Now, to understand the tactical revolution that defeated Russia's armoured might, you need to see the firepower in action. Find out more about the success of the Javelin system and the shift in modern military technology by watching our video on how the military show is tracking the collapse of Russia's armoured doctrine.